to Neverland.
You can do the exact same questions to all three classes.
Oh.
Was that helpful? Yes. No, it wasn't. Not even a little bit.
Which means nothing.
Okay, here we go. Question number 1 of the day. What is the sine of 60 degrees?
Three over 2.
Okay, so we know that. So then the question number 2 is, what is the sine of 120 degrees? Now, the logical response would be,
Yeah, 3 over 2, which would be.
so if the sine of 60 degrees is square root of 3 over 2, then logically I can see most people saying that the sine of 120 degrees would be 2 times that, which would therefore do that, which would give us that. Correct? But logically, that would make sense.
But are we being logical?
What's the square root of 3? 1.732, I believe. Trust me. We're in the ballpark. Right, Carmel? What's sine?
Opposite over hypotenuse.
It's opposite over hypotenuse, right? So, if the sine is 1.732, then what would that mean? What would that mean is true? That the length of the opposite side is longer than the hypotenuse, right? Does that statement make sense? If the sine were 1.732, then that would mean that the length of the opposite side is longer than the length of the hypotenuse, right? Because this number is greater than 1. Tell me about that statement. Can't happen. Yeah, it can't happen. So therefore, rule number 1 of the day comes up. And it deals with what you just said. Okay? The sine of theta and therefore the cosine of theta can never be what? Greater than 1. That is an impossibility from everything that we've said, right? And in fact, I'm going to show you something in a few minutes that's going to go further, it's going to give another level of proof to that statement. And this can't possibly happen because the opposite side can never be greater than the hypotenuse. And the adjacent side can never be greater than the hypotenuse. Correct? Okay. Let me ask you this. Ooh, that's really bad. Wow. It's getting worse.
Stop and fix it. okay. That's okay.
Good
As
enough.
good as we're gonna deal with for today.
Yeah, honestly.
Why don't you draw the circle first?
Can't draw a circle either. Anyway, so. If that point is 1 comma 0, what have I drawn?
A unit circle.
A unit circle. A unit circle. Center at 0, 0. Radius of 1. So, my next question becomes this. Wow, I really need to redraw that circle. If this angle is 60 degrees, what are the coordinates of that point?
Good question.
Thank you. How would we know?
We wouldn't.
We could, but we did something the other day that should help us here.
The formula thingy.
I just didn't hear you. No, don't have to do that. Has nothing to do with radians. If you flip back a day or two, you'll find it.
Well, back a day or two is covered in like art, so you can't really see.
Oh, that thing. Oh, sine of theta is y. And cosine of theta is x. Ah, remember that?
I don't remember where I wrote it down though.
And this works for the unit circle, right? God bless you. This works for the unit circle, and since we have drawn a unit circle, it should work here. So I ask again, what are the coordinates of that point?
Oh.
You should not need a calculator
Oh,
for
yeah.
this.
Root 3 over 2 from
What's root 3 over 2?
y.
The y.
And then 1/2 would be the x.
Because the sine of 60 degrees is square root of 3 over 2, which therefore means that the y is square root of 3 over 2. The cosine of 60 degrees is 1/2, which therefore means that the x coordinate is 1/2. Does that make sense? You okay there a little bit? All right. Let's say that angle right there, bless you, is 60 degrees. The blue angle. If that is true, what are the coordinates of the blue point?
Negative 1/2. Root 3 over 2.
Negative 1/2 square root of 3 over 2. Is that a reasonable statement there?
Yes.
I mean, from looking at the circle, logically that makes sense, doesn't it? I mean, if I had drawn a perfect circle, which I'm never going to do, but we're the same distance left that we were right, and we're the same distance up both times. Huh. If this angle here is 60 degrees, what are the coordinates of that point?
Negative 1/2, negative 3 over 2.
Negative 1/2
Negative square root of 2.
and negative root 3 over 2. Is that reasonable? I'll have one more question then. If this angle right here is 60 degrees, what are the coordinates of this last point?
1/2, negative 3 over 2.
1/2, comma, negative root 3 over 2.
Circleception.
we doing so far? Reasonable so far? Okay. If this angle down here is 60 degrees, this blue, then what's the measure of the green angle? It's 120 degrees. Yes? Therefore, what's the sine of 120 degrees? Don't overthink it. How'd you get it? Yeah, and sine is sine of y. Remember we talked about this the other day. We said for any point on the unit circle, the sine of theta is the y coordinate. Mm-hmm. So what's the sine of 120 degrees?
So it's literally the same.
So it's literally the same. Wow. It's kind of interesting. What's the cosine of 60 degrees?
Negative 1/2.
What's the cosine of 60 degrees?
1/2.
Cosine of 60 degrees is 1/2. What's the cosine of 120 degrees?
Negative 1/2.
Negative 1/2. Huh. It's kind of interesting, isn't it? So, the fact that those are all 60 degrees is kind of important, it appears. Because what does it imply when they're all 60 degrees? About the x's and the y's. They're all going to be the same with the possible exception of positives and negatives, right? So if I said to you, I'm going to create some angle where we have this 60 degrees thing in here, and I were going to ask you for the sine of that angle, you could tell me without question that the sine of that angle was going to be either square root of 3 over 2 or negative square root of 3 over 2. Does that make sense? We're going to go further with that. So if that didn't perfectly hit, don't worry. Those numbers, those 60-degree things that we're talking about, those are called reference angles. A reference angle is basically the distance an angle is from the nearest x-axis. A reference angle is the distance an angle is from the nearest x-axis. Oh wait, hang on, it's starting to make a little more sense. What did we say when we were going to draw those triangles that we've done for the last few days? Where did we say to draw those triangles? Did we say we always have to draw it to the x-axis? Yeah, and this is why. So that that triangle that we can create will give us the reference angle. Okay? So, I want to know, talk among yourselves, tell me 2 things about reference angles. 2 things that have to be true about reference angles. Take a minute, talk among yourselves. I'm going to do attendance. Talk in a minute, that's all.
And the terminal. It's the smallest angle.
It's the smallest angle. Of what? Okay. It might be, it might not be. That's all. So that's kind of a 50-50, but tell me about the measure of.
Do they all have to be the same measure?
I know what you're saying. We're going to get into that part in a minute or two. So hang on with that. Other things that have to be true with a reference angle. Any reference angle. The one side will be on the x-axis. The which side? The initial side. Yeah, these are all angles that are in standard position, for sure. Any other statements? Tell me about the word distance. What does that imply? True. What's the distance from me to the door? About 15 feet.
Oh, they're in degrees.
How far is it from the door to me?
15 feet.
15 feet.
Oh, distance.
It doesn't?
No. No, yeah, distance. Because like, it doesn't make sense for like, distance from me to the door is 15 feet, but distance from the door to you be negative 15.
Right, that doesn't make sense.
Yeah.
So therefore, what's true about distance?
They're all
That's
positive.
always positive.
It's always positive. Therefore, and that's why I use that word distance. A reference angle will always be positive. Fair? Reference angle will always be positive. Second thing about a reference angle that must always be true. Okay, you guys brought up the angle measure, the degree measure. So tell me about the degree measure of a reference angle.
Is it a radian or?
No, we're not talking radian. Could be. Keep going with that statement,
Oh, that's,
or in that direction.
it's positive, but it's not positive. It can't be counted.
Right, well, it is positive, okay, we've already gone with that, but go with degree measure, angle measure. Talk, speak to each other, speak to me, speak. Don't just sit, the more you toss ideas out there, the more we'll be able to funnel our way to what we actually want to say. So somebody say something and then we'll run with it, or you guys can run with it. Okay, somebody respond to that.
Somehow could have been 180.
Would like 180.
It's a straight line.
If you go past 180, I mean, but you're still gonna have to go past 180.
Okay, give me where you are now on that same type of statement.
Oh.
I heard some people talking.
Yes.
Ella, what were you guys saying?
He said no, because it's just like, a blip, like it wouldn't be 270 because the x-axis is just 90 degrees away from like a point out.
So therefore,
It can't be more than 20.
it can't be more than 180, okay? How do you feel about that statement? It can't be more than 90.
I like it.
Yeah.
I agree with it. If you go past 90 degrees,
Oh, you have to draw to the
The
x-axis.
x-axis.
Do you understand where I'm coming from when I say I want you guys to talk? Because you see what happens when you talk and you throw out ideas? You know, somebody says it can't be more than 180. And then people talk about it and they go, yeah, that's true. And then somebody goes, well, can it even be more than 90? Because once you get, and all of a sudden you guys come up with it perfectly. That's why I want you to talk. Because you're all incredibly smart and you have fantastic ideas. And even if you don't think you're smart in this class, you're smart. All right? And I've been telling you this all year. Fire stuff out. Say things. All right? Especially as the more new stuff we get into, the more you just want to toss stuff out. Okay? So what's the second statement on a reference angle?
cannot be more.
A reference angle will never be greater than 90 degrees. Can a reference angle be 90 degrees? When?
On the y-axis.
When it's on the y-axis. The reference angle from here would be 90 degrees. We'd be going to either here or here. So give me the angle measures of the x-axis. 0 degrees would be here, right? 180 degrees would be over here.
90 on top.
Remember, 360 degrees is going to be there, right? These are the numbers you're trying to get to. You're trying to get to 0, 180, 360. Usually it'll be 180 or 360. What numbers are we not mentioning? 90 and 270, because those are the y-axis. We don't want to go there. We just want to go to the x-axis. Okay? So the reference angle is the distance an angle is from the nearest x-axis. In other words, how far is it from 180 or how far is it from 360? That gets us a reference angle. Questions there? Does that make sense? Okay. Let's move towards next in this whole saga. So, a minute or two ago, we talked about if the, and we said if we have all of these 60-degree things here, we can now change the way we phrase that, right? We can say if the reference angle is 60 degrees, then the values for sine will always be the same. The only question will be positive or negative. And the same holds true for cosine, right? Okay, so let's talk about that a little bit more. What will dictate whether sine is positive or negative? What quadrant it's in.
All students
All
take
students take.
Mr. Ramsay.
Mr. Ramsay taught us.
That's a shame. Okay, so let's talk about this a little bit. Tell me about every point in quadrant 1.
All positive.
So the x is positive
And the y is positive.
and the y is positive. Tell me about in quadrant 2.
The x is negative.
X is
Y is
negative, y
positive.
is
X is negative, y is positive. In quadrant 3,
They're both negative.
Both negative.
x is negative,
Y is negative.
y is negative. In quadrant 4,
X is positive. Y
x is positive, y is negative. Now, we know 3 things. We know that the sine of theta is the y-coordinate. We know the cosine of theta is the x-coordinate. We know that the tangent of theta is y over x, or sine of theta over cosine of theta. So with that in mind, tell me about the sine in quadrant 1. Positive. What about the cosine? Positive. What about the tangent? Positive. Quadrant 2, sine.
Positive. Wait, no. Yeah, positive.
Positive. Cosine.
Negative.
Negative. Tangent.
Negative.
Negative. Quadrant 3, sine.
Negative.
Negative. Cosine.
Negative.
Negative. Tangent.
Positive.
Positive because it's a negative divided by a negative. Quadrant 4, sine.
Negative.
Negative. Cosine.
Positive.
Positive. Tangent.
Negative.
Negative. And so as you have heard, I'm sure, you need to memorize this thing. And so what we do is we figure out a way, okay, you've already stole my thunder here. All of them are positive in the first quadrant. In the second quadrant, sine is positive. In the third, tangent is positive. And in the fourth, cosine. For years and years and years and years, students have remembered this by reciting the phrase,
Students take.
take calculus. That's how students have remembered it for years. Telling you the truth. Well, Mr. Ramsire is a very strange human being. We know that, and I have told him that. I will tell you that the first school I ever taught at did not have a principal. We had a headmaster instead.
Ooh.
And the headmaster's name was Alan Strand, which works really, really well for this. Because some of the students, and I did not promote this, of course, Alan Strand takes crack. That was what they had said. I did not promote that, but whatever it takes to remember it. Okay?
I didn't promote it.
I did not promote it.
You may have laughed.
I would not have worked there very long. So, why? Why do we have this whole, and here's why. Okay? Because we want to be able to find the sine of 210 degrees. And to find the sine of 210 degrees, we are going to use a three-step process. And it'll be the same 3 steps every time. Okay? None of those steps involve the calculator in any way, shape, or form. And I promise you...
Is it going to give us the wrong answer?
hang on. Yeah. I promise you if you use your calculator in this stuff,
You will know.
you will get more wrong answers than you will right answers. Okay? I'm telling you that right now. So, step 1 will always be to find a reference angle. So for 210 degrees, what is the reference angle?
You just said that it can't. Okay.
Where do we get this reference?
Remember what a reference angle is. It's the distance to the nearest x-axis. So where are we going from 210?
360.
We're going to 180. How far is it?
Okay.
30 degrees. That's our reference angle. Okay? So the distance to the nearest x-axis. We're going to 180. That's the closest thing. That is 30 degrees away. Step 2. Use the chart. Okay? We're going to use the chart to find the sine of 30 degrees.
1/2.
The sine of 30 degrees is
1/2.
1/2. That is step 2. Step 3 is the quadrant. All students take calculus. Where is 210 degrees? It's in the third quadrant. And in the third quadrant, tangent is the only thing that's positive, which therefore means that the sine
It's going to be
is
negative.
going to be negative, and so the sine of 210 degrees is negative 1/2. It will always be the same sequence of events. Reference angle, chart, quadrant. Don't forget any of those because it will not work very well without.
I honestly thought you were going to start writing something extremely complicated up there. I was a little afraid for a second.
Say it again?
I said I honestly thought you were going to write something extremely complicated up there.
No, and that's why I teach it this way, because I think it's not complicated. Now, I want to show you something. Can I show you something?
Sure.
Why not?
There is another way to remember it.
Is it one of those really long textbook versions?
It's always one of those really long textbook versions.
Oh, yeah.
Just,
The special circle that I was asking you about earlier.
oh
this
boy.
year.
We should memorize that special circle.
Okay,
Circle of tangents.
this is the other option. You can memorize this.
Boy.
Heck no.
No thanks.
Now, I'm going to be honest with you. There are many teachers and there are many books that say this is what you have to do. I look at that and my first thought is absolutely not. Not going to do it, can't do it. It would take me a month to get any idea and I would not, no. So, you have 2 options. You can memorize this, or you can do reference angle, chart, quadrant.
I think I like that.
I think I like the second option.
Okay. Then, in that case, I will get rid of that.
Why don't they share this knowledge together?
I know, in SAT class, they were like, here's the giant circle of numbers, and I'm like, I don't know what that is.
How about no?
But now you do.
Yeah.
Okay? And so when you start talking about the sine of 210 degrees, what are the things you have to remember?
Reference angle.
How to get a reference angle. You have to remember the chart. And all students take calculus. So that leads us to our next question. What is the tangent of 315 degrees? Tangent of 315 degrees.
360.
That's 45 degrees.
Tangent of 45 degrees. Just square root 3.
Isn't it 10 degrees?
1. I always switch up those two. We were
And
talking about that yesterday too when you quizzed me on the chart.
And it's
It's negative because it's in the fourth quadrant. Definitely in the fourth quadrant.
yeah. I think so.
I think it's the fourth quadrant.
Wasn't there 60 degrees in each quadrant?
It's in the third quadrant. I think it's the fourth quadrant.
Yikes. I'm not drawing all over my math papers. What are you talking about? I don't do that ever.
You do it every day.
I never do it. I can't even go back to when I didn't do it. Ha ha ha. See, look at that. Look at that. I didn't do it here. I didn't do it here. I didn't do it here. Or here. Or here. Well, I kind of did it there. I didn't do it here. Everybody.
-1?
Yeah.
Awesome. Awesome. Difficult? No. But understand this, please. Okay? At this point, please, at this point you know how to do this, and it sounds like you guys didn't have too much difficulty with that problem. Okay? We spent a lot of time so far, we have more stuff to do, okay?
Boy.
But we spent a lot of time so far going over this and reference angles and this and stuff like that to make sure that it makes sense. Like it would be easy for me to just say, find a reference angle, memorize the chart, all students take calculus, done. But hopefully you start to see why, because one of the big places that students have issues is if sine of 60 degrees is square root of 3 over 2, what's sine of 120 degrees? And everybody, logically it makes sense, but everybody wants to go, well, that's twice as big as that, so that must be twice as big as that.